Everyone, today's video is part 2 of the topic temperature control and ventilation. I have already posted the first video, so if you haven't looked at it yet, I shall urge you to go ahead and look at it first before you proceed to watch this one. Our objectives for today are to understand temperature and unit of measurement, to describe the types of thermometers in relation to the principles by which they work. These are the types of thermometers that we'll be dealing with. We're going to explain the cooling effects of evaporation, latent heat of vaporization, sweating, and metabolic rate. We're going to explain the need for proper ventilation, the effects of ventilation, and we are also going to talk about air conditioners and humidifiers. Now, we are always talking about temperature and using temperature, but have you ever actually wondered what temperature is? Well, firstly, we know that matter is made up of atoms and that all atoms are constantly in motion. So if you look here, see, they are always in motion. Some have more energy and move faster than others. Temperature is an average value of energy for all atoms and molecules in a given system, right? So it's basically an average of the energy in the system. So the temperature measures the amount of energy in the system. So the more energy you have, then the higher temperature it will be. The less energy in the system, you'll have a lower temperature. And the temperature is defined as the measure of the degree of hotness of a body. The SI units are the Kelvin, which is represented as a capital K, and degree Celsius. Now, we've been seeing a lot of these lately, different types of thermometers. Anywhere you go, you're seeing one or the other, all right? Mostly you'll be seeing these in the stores, you'll be seeing like these in the labs and so on. So the main ones we'll be looking at are laboratory thermometers, clinical thermometers, digital thermometers, and minimum and maximum thermometers. So the first one is liquid and glass thermometers. These are more popularly used in the labs, such as the school, right? So it consists of a bulb filled with liquid, usually mercury or alcohol. And I'm sure you know this already. So this is the bulb, and it's filled with the expanding liquid inside here. A capillary tube is attached to the bulb and enclosed in a glass tube. So when the liquid in the bulb expands, it goes into the capillary tube. And it uses the principle of expansion. So when liquids are heated, it expands. And this can be measured using a scale. So these are the different parts of the liquid and gas thermometer. You are expected to draw this in your notebook and label it. Now you might be wondering why there are two types of liquids, mercury or alcohol. Well, the reason is that they are used for different reasons, right? So they have advantages and disadvantages of both alcohol and mercury thermometers. So firstly, mercury is a better conductor of heat, so it will expand faster when heated. Remember, it's a metal, it's a liquid metal, so it expands very quickly. It can measure high temperatures due to it having a very high boiling point than alcohol, and it is more visible than alcohol, right? I'm sure this is the one that we have in the labs. Now, one of the disadvantages now, it cannot measure very low temperatures. Compared to alcohol, it can measure very low temperatures. Mercury is more expensive and it is also very toxic. So if by chance, God forbid, if a thermometer breaks in the lab, you need to evacuate that lab. Now let's look at the clinical thermometers. Now these thermometers have a range of temperature that is very small, which is between 35 to 45 degrees. right? Because there's a very small variation in body temperature. There's no need to measure any temperature in the body below 35 degrees or over 45 degrees, all right? The base of the thermometer is smaller, so this here is a lot smaller than a regular liquid and glass thermometer. So the changes can be very easily detected, and that is what makes it a little more precise. A very narrow constriction in the capillary tube allows rapid expansion and contraction. So this constriction here allows this expansion to take place more precisely and more quickly. And it has a precision of 0.1 degrees Celsius, because 0.1 degrees Celsius is actually a big difference when it comes to fevers. So if you look at the chart here, we're only looking at Celsius, don't worry about the Fahrenheit, right? So a normal temperature of your body is 37 degrees Celsius, and this is a high fever, about 37.5. And well, these are the different places where you can place the thermometer to measure the body temperature. Now, out of habit, every morning when I wake up, I like to check the weather, right? So this morning when I looked at the weather, well, I came across yesterday's weather, and I saw this, maximum temperature and minimum temperature. So the maximum temperature was 29 degrees Celsius at 1500, that's 3 o'clock in the afternoon. And there was a minimum temperature, that's the coldest it got, at 2 a.m. in the morning. All right, and there's also the humidity that was measured at both times. This is the amount of water vapor in the atmosphere. All right, so these maximum and minimum temperatures are measured using a maximum and minimum thermometer. So this is what the thermometer actually looks like to measure these temperatures. So the maximum and minimum temperature thermometers are used for measuring the highest and lowest temperatures occurring during the day, right? Bulb C contains alcohol. A U-shaped tube contains mercury connected to another alcohol bulb. 2 mercury threads or steel indexes, right? So this is the bulb where the liquid is, right? And this is the steel index here. So what that does, it is able to measure 2 different temperatures. The minimum temperature is measured on this side, and the maximum temperature is measured on this side. So for an increase in temperature, the alcohol in bulb C, which is here, expands and pushes the steel index up on the right side of the thermometer. All right, so the steel index is pushed upwards, and this will mark the highest point of the temperature recorded, which will be the maximum temperature. Now for a decrease in temperature, the alcohol in this bulb will contract and the steel index will move up on the left side of the thermometer. Now when it moves up on the left side, then it will measure the lowest temperature recorded, and this will be known as the minimum temperature. The next type of thermometer is the digital thermometer. We have been seeing a lot of these lately, mostly this one, in all of the stores that you might be going in. All right, so how do they work? They contain sensors which produce currents dependent on temperature, which is connected to a digital display. It can measure very low or very high temperatures. Now what it actually does, it's a measure of infrared radiation. It's not something that you can see, but it's something that can be measured, right? So when they put this to your forehead or to your wrist, it measures the amount of heat radiating from you, and it converts it to a temperature. It's also used in furnaces, soils, and cooking. All right, I'm sure you've seen, well, these are like meat thermometers. You stick it in the meat and you'll know whether or not it's cooked. You don't actually have to wait for a certain color change. The temperature of the meat tells you when it's cooked. Right? There's also candy thermometers. These thermometers are used mostly in the home. So let's say you can always have one to keep at home in case someone gets a fever, you'll know exactly how much it measures. All right. Now these are highly responsive. They are less toxic than the mercury thermometers, and they are cheaper than the mercury thermometers. Now let's discuss the cooling effects of evaporation. So we know when a liquid is converted to a vapor, evaporation takes place. And energy is needed for this conversion. It doesn't just happen randomly. All right. Let's imagine a puddle of water on the road. Okay, so in that puddle, you'll have particles with very high energy at the surface of the puddle, right? Not at the bottom, it's at the surface. Where it's hottest is at the top, right? So these surface molecules break free of their attractive forces as it becomes a vapor. So let's say the sun is hitting the surface of the puddle constantly, right? The surface molecules will have the highest energy, and it will gain enough energy to break free of the attractive forces from these molecules here. And when it breaks free, it becomes a vapor. And that's why we say evaporation takes place. Evaporation only takes place at the surface. Now, the energy required to break free of the attractive forces from liquid to vapor is called latent heat of evaporation. Please remember that, right? You need to know this definition. Since high energy particles have left the liquid, right? So let's say these are the high energy particles. When they leave the liquid, the overall energy inside the liquid, it drops. And as a result, when the energy drops, the temperature falls, and that fall of temperature is known as cooling. Now, this is also a reason why sweating cools our body. So let's look at sweating and metabolic rate. So metabolic rate is the measure of the amount of energy used by the body per unit time to sustain itself and carry out all activities. So in order to do anything with your body, you must have energy. And the rate at which you burn this energy is called the metabolic rate. Some of you may have a high metabolic rate, which means that you lose weight faster. Some of you may have a slow metabolic rate, which means it takes longer for you to lose weight. Now, where does this energy come from? It comes from respiration, right? So the respiration provides energy for metabolic reactions, and as a result, we will heat up, and this heat must be released. Heat is released by perspiration and the exhalation of warm air. All right, so when that sweat leaves the body, just like how evaporation takes place with the puddle, evaporation takes place on the surface of your skin, and in that way it cools your body. Heat is also lost through exhalation of warm air, meaning the air that you inhale, it takes some of the heat from our body, and we exhale air that has a higher temperature than what we inhaled, right? And a combination of these two releases of heat, as a result, the body is cooled. Now, cooling is also very important in your surroundings as well. So this is what we refer to as ventilation. So ventilation is the movement of air in a manner such that fresh air replaces stale air in an enclosed space. Ventilation removes excessive heat from enclosed spaces and replenishes oxygen supply. Right? So if you look at this structure here, this is what a typical house design looks like. And the reason why the roof is shaped like this is to aid in natural ventilation. All right? So we know that hot air rises, all right? Which means when the air is heated at the bottom, it rises and it goes to the top of the roof here. The purpose of the vents on the side here is so that cool air can come in and push the hot air out. right? Now when the cool air comes in, it falls to the bottom because cool air is more dense. The cool air sinks to the bottom where it heats up again and then is lost through the top. So convection currents are formed within the home as well. So what is going to happen due to inadequate ventilation? Let's say if there were no vents at all, there would be dampness, heat buildup, lack of oxygen, and it will encourage odors. Adequate ventilation can be provided by an adequate number of windows in a room, the presence of fans, installation of AC units with dehumidifiers for damp air, and you can also have humidifiers for very dry air. Now in Trinidad, we have very humid air, which means we usually need dehumidifiers to dry our air a little bit. Now, we live on an island, which means that we are surrounded by water, and that water brings a lot of water vapor into our atmosphere, which gives our atmosphere a lot of humidity. All right. Now, how I like to express how humidity feels, it actually feels like the air is very thick, right? So when we have a high humidity, it makes it very difficult for sweat to evaporate. Because remember, we have water on the surface of our skin that needs to turn into water vapor to enter the atmosphere. However, if the atmosphere already has a lot of water vapor, it's going to make it very difficult to evaporate. High humidity can also short out electronics, and it can lead to mold growth, right? So too high of humidity means between 60 to 100%. It can cause all these things to happen: mold, bacteria, dust mites, and it can raise your allergies, especially if you have asthma, right? Too low of a humidity, that's where the air is very dry, between 0 to 40%. The air actually feels thin and it can cause nosebleeds, all right? Low humidity can cause difficulty in breathing, and it can cause dry skin. It can make objects brittle, and it can cause a buildup of static electricity, causing electronics to shut down, right? So too dry, which is 0 to 40%, can result in viruses and bacteria growth, respiratory infections, and yes, it can still affect your allergies and asthma. The ideal humidity range is between 40 to 60%. We do have this sometimes in Trinidad. However, on very hot days, especially in the dry season, it's well over 60%, right? I'm sure you've seen these in your shoes and shoe boxes and so on, right? These prevent humidity from taking place. It lowers the humidity. The desiccant is something that dries the surrounding air. It is also poisonous, so don't use it in your pantries and so on, right? So let's look at what was covered today. Temperature is a measure of heat energy in a system. SI units are Kelvin and degrees Celsius. The main types of thermometers are laboratory thermometers, also known as liquid and glass thermometers, clinical thermometers, max-min thermometers, and digital thermometers. You must know the difference between all of these thermometers and their characteristics. Evaporation takes place at surfaces and has a cooling effect, such as when we perspire. Ventilation is necessary to maintain a cool, well-aerated surrounding. Humidity is a measure of the amount of water vapor in the air. Too much, too high, or too low humidity can have devastating effects. Okay, so that is it for the topic of temperature control and ventilation. Remember, I need you to draw and label all the thermometers from this video. And also I need you to look out for a worksheet And after the worksheet, we'll be looking at some past paper questions. And I will also be sending you another video on how the thermometers actually work. Okay, so that is it for today. Any questions can be addressed to me on Edmodo. And let's continue our online learning until our next topic, which is energy and conservation. Okay, so that's it for today. Bye.